myself, Dr. Prashant Bhai. Welcome all the participants for the national webinar on fundamentals of industrial robotics, scheduling and sequencing problems in robotics, which is organized by Sanathana Research and Training Institute, unit of Sanathana SAMPRATHISHTANA, Mysore, in association with the Rotary Club of Mysore-West. Prayer is a process of talking to God in order to achieve a purpose. So let us begin this webinar by seeking the blessing of the Lord Almighty. Vakratunda Mahakaya Koti Surya Samaprabha Nirvignam Kurume Deva. Now I request Dr. Ramachandra CG, the Managing Director of Sanathana Research and Training Institute, to introduce the speaker of today's webinar. I also request him to welcome the guests and participants. Over to you.
A very good morning, one and all. So I take this opportunity on behalf of Sanathana Research and Training Institute, which is an unit of Sanathana SAMPRATHISHTANA, Mysuru, to welcome today's speaker, Dr. P. Sivasankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, and officials from Rotary Club of Mysore-West, participants from different parts of the country. So let me introduce today's speaker, Dr. P. Sivasankaran. He has completed BE degree in Mechanical Engineering from Pallavan College of Engineering, Kanchipuram, and ME in Industrial Engineering from Tyagaraja College of Engineering, Madurai. He has obtained his PhD in Industrial Engineering from Anna University in the year 2015. He is having total 12 years of teaching experience in various cadres, and currently is working as Associate Professor at Manakula Vinayagar Institute of Technology, Pondicherry, and he has published total 35 papers in reputed international and national journals, and also presented many papers in international or even national conferences. He has published books on quality management, process planning and cost estimation, managerial economics and computer integrated manufacturing, automation for excellence, etc. He has organized 20 plus workshops and guest lectures on recent technological advances in the area of industrial engineering. He is a peer reviewer as well as editorial board member for various reputed international journals. He is a life member of Indian Institute of Engineering, Mumbai, IAENG USA, and Teaching and Education Research Association, Eurasia Research. He is proficient in softwares such as Design for Assembly, AutoCAD, Robotics, etc. He has guided various academic projects for undergraduate as well as postgraduate students. He is regularly applying for projects or seminar grant, faculty development programs under various schemes such as DST, CSIR, NSNDM, and ASCT, etc. He has carried out a novelty research on the work titled Comparison of jute and sisal fiber reinforced composites using crushed PCB with the support of CETL Services Chennai. He has actively participated in various faculty development programs, national and international workshops at various institutions. He has delivered guest lectures at an institutional level, also at reputed industries, on the topic related to software applications and industrial engineering areas. So this is a brief introduction of today's speaker. The beautiful thing is that nobody can take it away from you. So that's why never stop learning. When we stop learning, then we stop growing. So even learning gives creativity. Creativity leads to thinking, and thinking provides knowledge. Knowledge makes you great. So knowledge is divine, knowledge is powerful, and it should be shared. A robot is a machine, especially one programmed by a computer, capable of carrying out a complex series of actions automatically. And even a robot is a type of automated machine that can execute specific tasks with a little or no human intervention. An industrial robot is a robot system used for manufacturing. Typical applications of robot include welding, painting, assembly, disassembly, and pick and place for PCBs, and packaging and labeling, palletizing, a product inspection and testing, all accomplished with high endurance. So today, successfully we have completed 4 sessions. This is the concluding or the session 5, where he'll be discussing the scheduling and sequencing problems in robotics. So with this, I wish all the participants will have a fruitful interaction with the speaker. Once again, thank you and all. Over to you, Prashant. So now I request the speaker to start his session.
So very good morning to one and all present here. Let me introduce about myself. I am Dr. P. Sivasankaran, currently working as Associate Professor in the Department of Mechanical Engineering, Manakula Vinayagar Institute of Technology, Pondicherry. So I welcome all the participants for the 5th session on fundamentals of industrial robotics, scheduling and sequencing problems in robotics. So before moving to the session 5, just let me consolidate the previous the 4 sessions in short quickly as a nutshell, and then we will move on to the today's agenda. So in session 1, we have started introducing about what do you mean by an industrial robotics and what are the different the program script that are available to activate various mechanical parts of a robot. And then the second session, we introduced about the concept called material handling robot. So how material handling plays a vital part in factory operation with the help of the robotics and automation. And we have seen different types of material handling robots for palletizing, for welding operation, as well as for machine loading and unloading operation. Then in session 3, we moved over to work cell concept in robotics. So there, what are the various different types of work cell that we can able to design for a successful placing the robotic machine into the work cell. Then continuation of session 3 is session 4. In session 4, how to avoid collision detection within the work cell. So we took one case study with the help of a software called RoboDK solver. So in that we have discussed about the various kinematic motion of a robotic arm, right? So these are the 4 sessions so that we have underwent so far in the previous the lecture. Now today is the last segment. So now we will see the agenda of the today's program about sequencing and scheduling problem in robotics and automation. First, let us get in touch with the introduction to concepts on sequencing and scheduling. Then we will discuss with the objectives of problem. Then why sequencing and scheduling of a robot is necessary by replacing the manpower. And what are the very challenging cases in robotic scheduling? Then finally, we will end the program with the conclusion. So these are the various order, the sequence in which we are going to discuss for today's lecture. First, let us straight away move to the introduction to the program concept. So scheduling problems. So what do you mean by a scheduling problem in manufacturing context, right? So scheduling that basically deals with planning and effective decision making in order to align the resources to do a particular job function. So scheduling have a time estimates. So at what time the proposed job has to be made readily available in the shop in order to load into the machine. So scheduling is a planning come decision making activity. So in general, scheduling problem means assigning number of jobs or task numbers and the number of resources along with due dates Okay, so when we want to load this particular batch of job to the corresponding machinery, at what time the job has to be kept ready after completing the manufacturing. So that is a due date. So but based on the due date, so we need to deliver the mode of dispatch and other the logistics function that comes hand to hand after the manufacturing phase. Okay, so each job operation have to be accomplished in that order by satisfying all the resource constraints like machineries, then tools and other equipments. Here we are interested in know about the operation of scheduling in the manufacturing context, although it has many other applications in different fields. So that we are going to see today with a block diagram, the scheduling logic with the help of the simple block diagram. So first let us discuss master production scheduling. So depending on the order, the customer order and the external demand forecasting. So based on that, the company will try to propose a master production scheduling. Okay, so in the master production scheduling, what are the projected requirement, the demand per period estimation that will be proposed very detailedly, and based on that, the capacity status, that is MRP, material requirement planning, that deals with inventory scheduling. So here we want to apply the proposed scheduling plan for the inventory, how much material we need to stock it. Okay, first thing, ordering. That is also a method of scheduling. How much you are going to order. Okay, so in both the cases, so scheduling plays a primary essential role, right? So in shop floor also, after making inventory availability, okay, so what are all the machineries that are available in the shop floor and how you are going to plan those machines for production. Okay, so that is nothing but availability of the machines. So here also scheduling plays a major role, that is checking the shop status. Then finally loading the jobs, that is scheduling the different allocation of batch number on the corresponding machineries. So scheduling is not only mean that only manufacturing the production of jobs. So it can also apply right from the material ordering, inventory planning and operation, and also machine availability. So it is a general term. Scheduling means allocating different n number of resource on n number of providing n number of facilities such that we need to focus the target event, that is output, the job output. That is the final target event. So whether that has been moved out from the shop floor exactly as per the customer the expectations or not, right? So this is the simple the example about the scheduling logic. So followed by the graphical illustration. Now we will try to understand exactly what do you mean by production scheduling from the manufacturing point of view, right? So here the jobs have to be manufactured in each machine in a particular certain order. For example, you take a lathe machine. So lathe machine will do turning facing operation. So we need to allocate this axisymmetric jobs, that is cylindrical shaped jobs. So only particular jobs can be fixed in the specific machines. Okay, so non-cylindrical jobs we cannot be able to position in lathe machine because it is a turning center, right? So all cylindrical shaped jobs that are available in the similar geometry that can be loaded in the particular order, okay, in a group of lathe machine. So this is called as a scheduling, which job are loaded in the corresponding machineries. And we have to note down the process timing for setting the job and also working the jobs followed by the machining operation. So at what time the jobs come out from that machine, okay, from the lathe machine, or other than lathe milling or shaping, okay, right? So the production scheduling means measuring the process timing for all given batch of jobs that has been processed on the specific machine. So the job can be denoted as J. That is, J varies from 1 to N. Okay, a set of jobs that may have a multiple number. Okay, so N number of jobs. Let us say 8 batches, 8 different jobs. Whereas mission I, N number of missions. That I varies from 1 to N. So 10 missions may be there, or more than 10 missions will be available in the shop floor. So our duty is to allocate all the job assignments on the available number of parallel missions, right? So the process time is denoted by P suffix ij. So what is the process time of job J on mission I? Okay, so that is the general notation. And also we want to find out what is the best possible route, that is the job sequence, in which order you want to channelize the job route, and also the time period according to the technological constraints. So this is how we need to follow the production scheduling operation before going to load the job into the corresponding machineries, right? So this involves a lot of planning, administrative process, right? Now let us understand what you mean by a production scheduling with a simple example called a computer assembly. Here, how scheduling can be applied. Let us examine a company called Tomcat Private Limited. So they are the leading assembling of computer components. So there are 3 main steps we can distinguish the process of scheduling. So the first one is scheduling of motherboard and microprocessor, then other hardware, the peripheral, the devices that are to be plugged in the motherboard assembly. And the next thing, what is the quantity number, the type of device that you are going to plan as per the customer demand, and preparing the route, that is how the job has to be traveled from one mission to another mission during the assembling process. So preparing the route through the steps, so that is given by the technological constraint, and that is not depend on the specific order of the customer. So the technological constraint is nothing but what you are managing inside the factory that depends on your company operation. So based on that, you need to meet out the customer outside demand. So here the further continuation according to the previous example. So it has been showed here. So section 1, that is plant 1. So which is purely carried out by the motherboard and microprocessor, the scheduling of these 2 components. And section 2, peripheral devices, and section 3, quality testing and the finishing process. That is whether all the the intricate components are assembled in the correct sequence or not. Okay, so this is done by the quality engineering and testing department people. So on each section, one worker will be performing the corresponding operation, but a new order, for example, a new batch of order will never disturb the existing work progress. So this is the scheduling rule. If a particular work is going in the current mission, so a new batch of order should wait until and unless the previous job operation gets over and moved out from that particular mission. So the new order should not start until you complete the previous batch. So this is the logic to be followed, the scheduling operation. So let us assume that the order cannot overtake other order. Okay, so by following the same job sequence for all the steps of CPU assembly, right? So the environment for the scheduling. So let us take, there are different types of the mission scheduling missions. So single mission scheduling problem. There are different types of the sequencing and the parallel processing of jobs and mission in scheduling environment that we are going to categorize one after the other. So single mission scheduling problem. The next one, the parallel mission scheduling problem. Then flow shop scheduling problem, flexible job shop scheduling problem. So these are the things we are going to discuss now concurrently in the next, the following slides. So what do you mean by single mission, parallel mission, flow shop, and flexible job shop, right? So first let us take the problem statement of the single mission, the scheduling problem. So what do you mean by that exactly? So it is one of the most very basic and simplest mission environment. So it will have only one single processing center, and a group of batch of jobs will be waiting in a large queue. That is one of the bottleneck, one of the drawback we want to understand here in single mission scheduling problem. Because here the number of service center is only one. There is only one machining center. So as a result, there occurs a huge waiting time. Okay. So to overcome the bottleneck problem of single mission, the next classification is parallel mission. So a group of the mission which are similar, identical in terms of operation. Let us say, for example, group of lathe missions that are arranged as per the sequence, or a group of milling missions, horizontal or vertical milling missions arranged in the same sequence. So these are coming under parallel processor. These type of the problem, the scheduling missions coming under parallel processing type. Okay, so which has an identical operation. Right here, there is no kind of the bottleneck problem. So because all the missions will have a similar operating characteristics, so we can divide the workload and we can equally allocate each the job batch of jobs in the parallel. Right, so it is a sequential dependent problem, the flow chart scheduling problem. Okay, even you can take a computer assembly line, also a best example for the flow chart scheduling problem. The next one is a flexible flow chart problem. Here there are n number of stages of mission, multiple stage of missions that are kept in parallel as shown in the graphical illustration. So here the main the advancement here, a job can be processed on any mission in each stage, because all the missions are does the same job operation. So we can put in any sequence, it will not affect the process time, the end outcome, the job completion time. The next one is a job shop. Okay, so the job shop, it is considered to be a highly typical scheduling problem, because here the routing is entirely different. You take the first sequence, so the job 1 has to pass mission 1, 2 and 3. So you take the second job sequence, the job order, so sequence is entirely different. So according to the production, we need to realign the process sequence. So the second mission comes as a first priority. The M1, that is the first mission, comes as the second priority. So likewise, the mission position, the sequence that can be realigned according to the job nature and also the production order. Okay, so the job shop follows a different route for every batch of jobs. It is not like a flow shop. So that's why I told you it is a very complex problem. So here the last one is a flexible job shop scheduling problem. So we understood that what do you mean by a job shop scheduling problem. By keeping that in mind, so we can allocate n number of parallel processing the job shop scheduling environment. So we can able to relax the scheduling time constraint, that is a limitation. So any job can able to process on any mission in whatever the time according to the capacity of the mission and also the capacity of the jobs that are to be loaded in the corresponding missions, right? So we can able to relax the time estimate, the scheduling time estimates without fixing any tight boundary limit, that is the due dates. So now let us understand what are the different types of constraints in the scheduling logic. So one is the release dates, then another one is a setup time. Setup time is nothing but job loading and unloading time. Similarly, tool adjustment timing, okay, before starting the operation. Then pre-emission is nothing but, so we should not disturb when a particular activity is going on in the mission. Okay, so the pre-emission is not allowed. Then precedence constraint. Each the job order, check whether is carried out as per the assembly order or not. If the scheduling belongs to the assembly line, so whether all the job orders are carried out according to the sequence of the product assembly order or not. The next one, blocking. So sometimes if there is any line failure or huge group of job orders are waiting in queue, so temporary blocking will take place. So in that time, you need to break the tie, and depending on the time priority, we need to take the job assignment that has to be scheduled as a primary priority. And there should not be any waiting time. The jobs should move continuously in all the processing workstations without having any waiting time. Okay, so how that is possible? Now we are going to apply the concept of the robotics and automation in scheduling. So how this can be rectified by replacing manpower through automation, through robotics and automation in scheduling operation. So here, first thing, we need to instruct a machine, a robot, a pick and place robot type assembly. So first thing, we need to give a common priority that assign the task as per the sequence of job. So a robot has to understand the problem. So which job has to be assigned first. So it will try to work like a human being. So all program data we need to feed to the pick and place robotic arm control machine. So such a way that it will try to read the total entire environment. So from the rule-based index, it will try to initialize, for example, job 1. So it has to order as a first priority, then it will allocate as a primary assignment. So job 1 has to be loaded. So until job 1, until the completion of job 1, it will not go to job 2. Okay, so avoid parallel interference. That is nothing but, so till the completion of primary activity, it will not go to the parallel activity. Okay, right? Then ensure whether the continuous availability of job planning are carried out effectively or not. So these are the 3 objectives, the challenging cases for robotics and automation. Okay, right? If you want to rework all the scheduling, the manufacturing, the scheduling environment using robot and automation, right? So we need to think about the amount of the expenditure from the financial point of view, and the cost of buying the software, and how you are going to train each and every robotic machine by condition monitoring every day in and day out. Okay, right? So these are all the challenges, right? So why in manual scheduling the problem occurs? Because human beings may become dead. Gradually they become fatigued due to the continuous overpacking of loading operation. So due to mild the confusion, they may change and do the schedule of operation in certain cases. So that may lead to have a wrong projection of deadline, and sometimes that may lead to accidents also, due to manual error. So that is why the robotics and automation are used for the job task allocation, that is a scheduling environment. Okay, so in this research, a great deal of work has been done by various eminent philosophers around the globe to consider the robotic mission for the part scheduling and the sequencing in a flow shop workshop, right? So each stage in the manufacturing process has got one or more parallel missions. So it is not easy for a human worker to take a big headache to process all multiple operations manually. So that's why robotic works have come into picture that will serve stage by stage all the different multiple activities through automation. And further continuation comes in the next slide. So there are different types of robotic work cells that are used that may differentiate based on the characteristics. Okay, cellular layout. Okay, U-type assembly line layout. Okay, these are the different types of the work cell line layout, so that we can equip for construction of a work cell unit Okay, then depending on the travel time and the quantity of robotic machines and the type of parts that you are going to use it for a parallel processing operation. Okay, so everything we can able to plan and schedule in this particular area, and also we can able to improve the accuracy and by controlling the error by performing automatic scheduling compared to manual scheduling. That is quite easy nowadays. So now let us discuss a case study which I published during my PG when I'm doing my industrial engineering course in Tyagaraja College of Engineering, Madurai, in the year 2008 to 10. So this paper has got published in the year 2009. So efficient heuristic to minimize make span. What do you mean by a make span? Make span is nothing but finding out the total job completion time, right? So here I have made an attempt to develop an efficient heuristic algorithm to reduce the make span time, job completion time, in a single mission scheduling problem with unrelated parallel missions. So single mission scheduling problem is nothing but the number of operation is said to be only one. For example, you take turning operation in lathe, it is said to be only one operation. That one operation is carried out under different mission with varying speed operation. Missions may be same, but differentiated with according to the RPM, speed characteristics. So that is an assumption I took for my problem during my PG, the project work. So let us discuss the case study, the abstract of my work, and also the method, results, and discussion. So this the work entirely deals about the design and development of efficient the heuristic algorithm in order to control, to minimize the wastage, the job completion time by scheduling n number of jobs, independent jobs on m parallel missions. Okay, so as I clearly made out here, so my problem is not a sequence, a dependent problem. So it is a independent problem. So I can load it in any order, but somehow it should not affect my job completion time. Okay, I should not compromise with the maximum job completion time. Okay, so my objective is to reduce the maximum job completion time to the minimum extent, such that I can contribute my remaining time span for some other productive work to do it. If I waste most of my time in doing the same repeated jobs, right? So here the problem of scheduling the jobs on unrelated parallel mission is said to be combinatorial in nature. That is NP hard. Okay, so non-deterministic polynomial type of problem. So this kind of problems cannot be addressed by normal way of handy calculations. So we need an heuristic algorithm and substitute a mathematical model, a numerical modeling procedure to compare the solution of efficient heuristics along with respect to the mathematical model. Okay, so here I made an attempt to compare the solution which has been attained by the heuristic along with the numerical modeling in such a way that how my make span time, which has been solved by algorithm and also parallelly by the mathematical model, how far it gives a significant or insignificant difference for my problem. Okay, so let us continue with the abstract, the next following slides. So here the mathematical model linear programming approach is suggested for my problem. Since it is a production scheduling, job allocation, task environment, task allocation type, so I prefer the linear programming model. So a factorial experiment is conducted, ANOVA, a full factorial ANOVA experiment is conducted at last by taking two factors, namely method. So here I took two methods, algorithm and mathematical model as the first factor, and second factor, problem size, number of problem size, that is number of missions. Okay, so number of missions and jobs. Okay, that is my second factor. So it is found that from the results, so there is no much significant difference between the results attained by both heuristics and mathematical model that we are going to see at last in results and discussion call. So characteristics, the next one, we will understand the characteristics of the single mission scheduling problem. So here, the main essential characteristics of single mission scheduling problem, along with unrelated parallel mission, are listed here. The first thing, there are n number of independent single operation jobs will be there, and parallel missions, m number of parallel missions will be contained in the shop floor. So those m missions should be continuously made available. So care should be taken that all the missions are properly engaging conditions or not. So none of the missions should not be kept idle. So that is considered to be a wastage. If any one mission considered to be waiting or idle, so it is considered to be a negative bottleneck problem. So these are some of the theoretical assumptions I took in my problem. And TIJ, that is nothing but the process time of job I, job J on mission I, right? So these are the list of the different the characteristics I took for the single mission scheduling problem. The next thing, mathematical model to minimize the make span in scheduling n number of jobs on unrelated parallel mission. Okay, so what are the factors? What are the list of the parameters I considered for describing the mathematical model? So here I took a variable called n, the number of jobs, and m number of unrelated parallel missions, and process time Tij. So based on that, so this is my objective function. So I have structured the objective function equation like that. Capital M, that is nothing but the make span. So I want to control my maximum make span, that is maximum completion time, job completion time. I want to minimize that. Okay, so I want to minimize the maximum job completion time by finding what is the total the job sum. Okay, Dij is my total job completion time, and Xij is nothing but the unknown decision variable. Because algorithm, when you are solving this problem in algorithm, we may not be knowing that which mission will try to have a maximum job completion time. Okay, so we need to give n number of alternatives, whether first or second mission may have a maximum job completion time. So by identifying that, we need to shift a portion of job to the neighboring mission such that we can able to reduce the fraction of the make span time to the minimum extent. Okay, so here this is the job index table, the generalized format of process time. So here there are m number of parallel mission and there are different jobs are there. Okay, for example, how to read this table? So mission 1 requires a process time of this much minutes or hours on job 1 on first batch. Okay, similarly for second batch, it requires a certain amount of time to schedule on mission 1. Likewise, mission 2, 3 up to maximum number of mission availability. So these are the different things I have feed it as a input data in both mathematical model as well as in heuristic algorithm. Okay, and this is my final the model, the mathematical model subjected to the constraint. This is nothing but the task assignment constraint. Xij is equal to 1. On any one mission, I need to assign the job, because in every mission, only one job can be allocated at a time. Not more than one batch of jobs will not be allocated as per the scheduling principle. Okay, right? Now coming to the steps of algorithm. So developing algorithm to minimize development of efficient heuristic algorithm to minimize the make span of scheduling jobs on unrelated parallel mission. So the first step according to the algorithmic procedure, so feed the input data into the program. So what are the independent jobs and how many number of missions you are going to take, then job status index, then what is the mission completion time. So everything you need to feed into the program as a primary source to the computer. Then step number 2, assign the jobs to the mission. The algorithm will try to do this operation. So it will give a control to the mission. Okay, so it will instruct the robot to find out the job sequence. So which order the job has to be assigned. And setting the job status index. For example, job 2 has to be assigned first. So it will initialize the job status index. So that has to be come front. Then find the mission which has a maximum the job completion time. Okay, from the available missionaries. Then shift the jobs after finding the maximum job completion time. Shift some of the jobs which has a maximum the job completion time to the neighboring mission. That may give a possible reduction in the make span. Okay. Then step number 6, find out again the job status index, whether if there is an improvement in the job completion time or not. So go to step 8. Suppose if there is no improvement, finally update that as a complete solution. Okay. If there is some improvement, then update that as a final result. Okay. After reducing the job completion time. Okay. Right. Then finally, we need to stop the operation. So this algorithm is processed with 9 different logics. Okay. And this is the logic for the heuristic. By considering Gantt chart as a principle, as a theoretical principle, okay, so the algorithm can be solved according to the Gantt chart theory. Okay, so every batch of jobs has to be loaded independently without considering the time-bound constraint, that is due date. So here in my problem, I did not brought due date as a primary constraint. Okay, so instead of that, I relax my constraint as independent jobs. So I can allocate the job in any order in different missions such that my make span, this is my make span time, the last job completion time in every mission. So I have to find out which mission has maximum make span. I want to reduce that to minimum possibility. Okay, so this is my logic of my algorithm, the efficient heuristic development for single mission scheduling problem. And this table which gives my results by solving different problem. So 2 by 5, that is nothing but 2 missions and 5 jobs. Okay, right? Similarly, 2 missions and 6 jobs for every iteration, for 2 iterations. So small problem to maximum problem case. So I took, and these are the results, job completion time results in minutes that has been recorded. Okay, for different problem cases. Okay, and the comparison between algorithm and model that also given here in the table. So let us take for example first problem 2 by 5, the problem size for a 2 mission and 5 job. Okay, so make span time by solving a heuristic method, I'm getting the job completion time 21 minutes. The same result I'm getting for model. Okay, so for solving mathematical model. So there is no much significant difference between algorithm and model. Okay, right? The heuristic is a near approximate procedure, whereas mathematical model is a optimal. It will give you a global optimal solution. So here you can see when we change a problem size as a 3 mission and 6 job, here I may get some difference between the model and the heuristic procedure. By solving heuristic procedure, I'm getting the job time, process time as 15 minutes, whereas the mathematical model gives a 14 minutes. So some minute difference. Okay, not much significant difference, right? So that depends upon the number of the problem variables that you are going to list it out when you are solving both algorithm and mathematical model. So now we are in the end of the case study. So let me summarize all the stuff which we have discussed right from the beginning, from the beginning of the session. So initially we have started introducing about the importance of scheduling and sequencing in day-to-day scenario, and then we restricted our application to the manufacturing area, how scheduling and sequencing operations carried out. Then we took some certain examples, a computer assembly line, then different types of scheduling problems, then followed by a case study of my own work. Then now coming to the closing remark, the conclusion of the program. So from these basic input, it is clear that the production scheduling problem plays a major role in both the planning and decision making function in a manufacturing organization that decides the early completion of various the products and the key components of the final assembly. And this paper considered the problem of scheduling n independent single operation jobs on m unrelated parallel missions in order to control the minimization of make span time. So since the objective here taken is minimizing the make span for the given problem, which comes under the combinatorial category. So by solving the problem under different combination for by using both mathematical model and heuristics, so there is no infeasibility occurs in this work. So hence this concept can be recommended in future when the world is begun to change to completely to digital revolution after 20 or 30 years from today onwards next future. So we can recommend these kind of concepts to many manufacturing industries, automobile manufacturing industries, along with the application of robotics and automation environment to successively plan the scheduling jobs without any error as per the systematic sequential order. So with this, I thank all the listeners and the participants, and also I thank the program in charge, the coordinator, for giving me the chance to share my basic views on scheduling and sequencing problem in industrial robotics. Thank you, one and all present here.
Thank you very much, sir, for your very informative and wonderful session. Now, I request the participants, if you have any doubts or queries related to this session, you can unmute yourself and interact with the speaker.
So any participants, you have any clarifications or any doubts, directly you can unmute yourself and you can ask the speaker and get it clarified. So if there are no questions, you can continue, Prashant.
Okay, sir. So I request Dr. Ramachandra CG, the managing trustee of Sanathana Research and Training Institute, which is a unit of Sanathana Samprathishtana, to summarize today's webinar.
So first of all, let me thank the speaker so far as a wonderful session. And today, as I told at the beginning, successfully we have completed 5th session. This is the last session for this particular topic which you have selected. So during the first session, session 1, so he has discussed the fundamentals of industrial robotics actually. So about the basics of robots and why the industrial robotics are required, what is the application of it. So many things he has discussed. And in continuation with that, in the session 2, so he has discussed various material handling systems in robotics which are used. Those things he has discussed with a case study. And session 3, a robotics work cell design. So how the work cell has to be designed in robotics. So this also with an example he has discussed. In the previous session, session 4, the simulation of robot line automatic motions, that is kinematic motions using collision mapping planner he has discussed in detail. And today's session, the scheduling and sequencing problems in the robotics. In that, he has discussed the basics of the introduction of scheduling problems in the industrial robotics. He has discussed, and what are the scheduling logic. So, with the help of a flowchart diagram, he has discussed, and the production scheduling he has taken particular case, and with an example of computer assembly, how the production scheduling is done clearly as explained, and what are the scheduling environment, and what are the constraints which are required. So those things also in detail he has discussed, and even the main objective of scheduling in robotics, and why the scheduling is required in robotics. Those things are discussed, and his own case study he has explained how exactly this the scheduling is important, as well as the scheduling as well as the sequencing problems in robotics. At the end, he has concluded with this case study. The production scheduling is the key for the early completion of the products, especially in assembly. So with this, today we have come to an end of this 5 session, the industrial robotics and related the information. So I thank all the participants also from the beginning. You are with us, and you have attended all the session. Once again, I thank Dr. Sivasankaran for his continuous support with for conducting so many sessions with our institution in collaboration. Thank you, Anandal. Over to you, Prashant.
Thank you, sir. Gratitude is the essence of humanity. I thank Dr. P. Sivasankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, for accepting our request to be the resource person for 5 consecutive sessions on industrial robotics, fundamentals of industrial robotics. Even he has delivered a very useful session on scheduling and sequencing problems on industrial robotics today. So I thank him personally on behalf of and on behalf of Sanathana Research and Training Institute for delivering a very informative session. Thank you very much, sir. I thank Dr. Ramachandra CG, Managing Trustee, Sanathana Research and Training Institute, a unit of Sanathana SAMPRATHISHTANA, Mysore, and officials from Rotary Club of Mysore-West for their involvement in organizing this webinar. I also thank Sri Lokesh CG, President, Dr. Raghavendra Prasad MD, and Dr. Shantaraja Aras, Srimati Bhagya Gopal, Board of Trustees, Sanathana SAMPRATHISHTANA, for their support extended in organizing this webinar. Finally, I thank all the participants for your support and active participation in this webinar. Thank you one and all. Have a nice day.
Thank you.